Welcome to the Filecoin IPFS workshop with Jenks. We're all really excited to have you here. If you could, can I please ask you to put on your cameras? It's much nicer to have a workshop where we can see all your faces. And also, I'd love you to all put on your cameras so I can take a screenshot to post on Twitter. And yeah, it would be awesome. Thank you very, very much. I very much appreciate it. We're going to drop some important links in the chat box. Introduce yourself now, say who you are and what you're building. If you know what you're building, it would be great to see what you're all working on. So Jenks is going to do the workshop today, and he wants interaction. So if you've got any questions, please just pop it in the chat box. He will answer as he goes along. And yeah, I'll be posting a few links in the chat box too. Again, please put on your cameras. It would be very much appreciated. Awesome. Jenks is our developer advocate from Filecoin. Welcome and thank you so much for coming here today, Jenks.
Thank you, Alex. Hi, everyone. GM, wherever you are. I'm Jenks, developer advocate at Filecoin Foundation. My mission is to make developers superhumans as quick as I can and as pleasant as I can during the progress. Welcome you all to this workshop. Today, I will talk about IPFS and Filecoin. Please don't be shy with your messages. I would like to see as many messages as you can during this session. I will even pause to answer some of your questions if it's relevant to what I'm talking about at the time. So yeah, without further ado, there's so many lovely faces here. Thank you all for joining. I'll get started right away. This is a long talk. I'll try to make it as interesting as possible because talking about file system might be boring, but I'll try to make it as easy as possible and also as interesting as possible. So the agenda, I'll talk about what IPFS and Filecoins are, the concept, technology, and developer tooling. This is a hackathon, so we'll talk about tooling that you can use in this project. I'll talk about IPFS and Filecoins use cases and projects, some of the Filecoin for social good initiatives, and some possibilities and opportunity to inspire your ideas for the hackathon. And also I'll talk about what's new, what's upcoming for Filecoin and IPFS. There are two really important projects, one called Filecoin Virtual Machine and one called Retrieval.market in Filecoin that are very exciting. I'd like to talk a little bit about that. And also, finally, the resources of getting involved and staying in touch with us after the hackathon. Before I start, I would like to explain a few organizations and a few names to you, actually. So on the top two, you can see Protocol Labs and Filecoin Foundation. These are two organizations that is very important in our ecosystem. At the bottom, you will see IPFS and Filecoin. These are two technologies that are very important in our ecosystem. So Protocol Labs is an open source R&D lab, building protocols, tools, and services to improve the internet. And they are truly believing in the next versions of the internet being the revolutionary change in human progression. So they would like to reinvent the internet. So they're inventing the bottom layer protocols, but also trying their best to make open source projects that other Web3 projects depend on, such as IPFS, libp2p, IPNS, IPLD. Filecoin Foundation is an organization that is most interested in the longevity of Filecoin project. It is a blockchain governance project, if you like. It is the steward of the Filecoin community, and they are aspiring to put the power of humanity's most important information back into the hands of everyone. So these are two organizations and two technology that are very important is IPFS, which stands for Interplanetary File System. It is a peer-to-peer protocol that is making the web upgradable, resilient, and more open. Think of it like HTTP that you use every day right now, but a peer-to-peer version of it. A bit like BitTorrent, but it's on a professional level and made for developers and for developers to build their wonderful projects on top of Filecoin is a decentralized storage network that is trying to store humanity's most important information. It is also a marketplace for people to trade hard drive spaces. So if you want to store something for people for money, you can join this network. And if you would like to store using decentralized, world's largest decentralized storage network, then you can purchase Filecoins and use it to facilitate storage of your data. Think of it as a Airbnb for data. So where are we in the whole wild Web3 stack? If you look at this graph from Edge and Node, you can see that where we are on the file storage place, you will see IPFS and Filecoin. IPFS is a protocol that enables peer-to-peer file system, file sharing, and Filecoin is the blockchain project on top of it. One of the big pieces of the Web3 stack puzzle is how do we store data in a way that is aligned with the mission we're in. So in a distributed way, in a verifiable way, censorship resistance that is owned by the people, but still bring the benefit of Web2 that is easy to access, scalable, cheap, and efficient. So IPFS and Filecoin are the perfect match in solving this kind of problem. And fundamentally, storage is the most important thing of the internet. The content has to go somewhere. A website is in the format of files stored on servers after all. So it will underpin the whole infrastructure of Web3. So you can see this corgi on the right-hand side on the bottom. His name is, he or she's name is Biscuit. He will be following me for the duration of this talk. It is our mascot. We use corgis a lot. We have some wonderful swags that are corgi themed. They're really cute. I'll explain the concept of IPFS and Filecoin next. But before I start, I need to explain a movement that is happening right now. So centralization has caused many problems right now. Think Microsoft, Google, Amazon data centers. There are a few platform companies that are centralized, and all of our important stuff are stored on their infrastructure. When they go down, quite often half of the internet goes down, and we can't function as a society. Now to solve this resilience is an engineering challenge. A lot of platforms actually introduce multiple systems and multiple layers of systems to be able to provide reliability and redundancy on their services. But to really solve this problem, you kind of need to solve the centralization problem where everyone goes to one single spot for resources and services. So decentralization is happening right now. And that's one way of making things performance scalable, secure, and efficient. But it is moving in generally to a distributed way where users are powered to provide services, and services are censorship free and resistance, I should say. You have privacy between nodes, but also you can trust each other or trust in a trustless way to transfer information. And you don't break off information in silos. So imagine not being able to bring data from one platform to another, whereas in a distributed way or in a Web3 way, people can bring data freely from one to another. So over the next 40 minutes, I'll explain how IPFS, this P2P hypermedia protocol for content addressing, and Filecoin is able to decentralize the world's storage system. So I'm going to start with IPFS and interplanetary file system, one of my favorite acronyms in the Web3 world. What is the file system? So the file system are files plus folders. Any file with any content, it can be any format. Why interplanetary, you may ask? Because it's we're convinced that it is a way to upgrade the web in a way that we could still work when the network stretches across planets. The idea of IPFS is that if you're on Mars and you're trying to take 1 hour to make a request, go down, come back from Earth, basically trying to get the current internet model to work, it won't work because of the sheer distance and latency that is involved. However, if the content is right there cached on Mars, like half of the internet or in the entire internet is actually cached on Mars, then that person would just request the content only if it is missing from Mars to the Earth. Rest of the content can be served on Mars right away, which will leave a really good performance there. So IPFS is designed from the ground up to be distributed. There is no central authority server that are storing content, and there's no central server that needs to be contacted to be able to find the content. So it is truly distributed, resilient, and offline first. IPFS gets rid of content addressing, which is what we're used to right now. When we visit IP address, we're trying to find out where the server is, and then we find where on the server the files are, and then try to find it. IPFS is address content based instead of what it is. It's asking what it is instead of where it is. So it replaces a folder or a file location with a content ID instead of a web address. So let's take a look at how things are stored on the computer. So usually you will have a file system, and you have which drive it stores on, the path to a certain file. And the current internet works the same, right? So you have HTTP, and then you have a domain, which translates to an IP address. And that's asking, like, where is this server in the world? And then it finds it, and then you use a path to find the file. In IPFS world, it works a little bit differently. In IPFS, every content gets hashed into a fixed length called, it's a hash function, actually. It's an ID called a CID, content ID. And in IPFS protocol, you provide the CID, which is like your URL. And then it's the fingerprint of the file. So it doesn't matter where it is, it disregards where it is, and it serves the content. I'll talk about how that works in a minute, but let's talk a little bit more about the CID and how it's made. The CID is a cryptographic hash function, like a fingerprint of that piece of content. Every piece of content can produce a different fingerprint. All of the fingerprints are of the same size, regardless of amount of content they represent. So no matter how big the file is, it will always produce a fixed length fingerprint. This fingerprint is named content ID and can be reproduced anytime from original content or by hashing it again, which means to obtain a piece of content after requesting a content ID, we simply use a function again to just get the verifiable CID anywhere in the network. So you could be uploading from one node, from another, it will still give you the same CID. So if we use these CIDs everywhere, we can basically have folders and different layers of the file systems, and each layer will have their own unique identity as well. So IPFS uses a structure called Merkle direct acyclic graphs, Merkle DAGs. It allows location-based addressing to be content addressed in a single step by replacing the location with the root CID of the content, and the subpaths all stay the same. Where you can see our top level folders are root content ID. It then has two child entries corresponding to two folders, and those folders have other entries corresponding to the files. Each node entry has a different CID, so the color on this graph represents unique CIDs. You can see how every single node on this file system has a CID, and we can address it by what it is rather than where it is. It's translating from a location-based stuff a system to a content-based system. So for example, one of the benefits is deduplication in the system. If a folder, let's say we created a new folder rather than user 1 and user 2, and in this folder we have a doge.png file that is repeated between the two systems. When it gets made into a Merkle DAG, it will actually duplicate, because the file system will know that the doge.png is the same file as what is stored in user 1. So instead of actually duplicating the data in the new folder, what it does is it will refer to the old data that's especially the same thing. So it will refer to that. So in this system, all the content is verified, and if it changes, you have a CID change. If it doesn't change, then it's the same thing. So it won't actually duplicate it. So it's naturally deduplicating the content. So that's how the file system works. But it is a network. It needs in a network, you need to send message from one end to another, and being able to find things and serve it, and it works like a cluster or a swarm. How exactly does the messaging works is quite interesting, and it works by in IPFS world, the messages go through something called a content routing. All of the peers in the network, a swarm of network peers, will connect with each other, and being able to provide services to each other, and allow people to find content in the network, one another, by relaying the message in the network. So let's forget that we're talking about the file system. Let's pretend that all of the computers in the world that has IPFS node implementation are actually peoples. And if you want people in the same room to talk to each other efficiently, it will help that if other people are speaking the same language. A common language will facilitate communication very well. And it also helps that they know who they are. So you know the names of the people. And then if they have a way to verify what who they claim they are, who they claim their identities, then it will be very effective communication. So it's the same with IPFS, except we identify the peers in the network with peer IDs, which is a unique identifier. And this identifier is linked to a cryptographic identity, which allows each peer to communicate securely through a encrypted channel. So they can talk to each other in the same language, but also still have their own secret without telling the whole network about what they're talking about. In order for peers to be able to discover each other, they will have to provide a couple of services. They need to be discoverable, and they also need to be routable or reachable. And we use a technology called distributed hash table, or DHT in short, to be able to do this in IPFS. You probably have heard of distributed hash tables, and you probably have heard of hash tables, and distributed hash table version is not too different. Apart from the need, multiple peers need to maintain a single hash table. So it's like a phone book, except everyone keeps a part of it. And when asked, everyone will present what they have and help each other to find that piece of content or address or whatever it is that is stored on a DHT. It's more efficient with the general broadcast, but IPFS Protocol Labs, the smart engineers at Protocol Labs have invented a new way called a gossip sub that allows a very efficient communication between nodes in the peer-to-peer network without wasting a lot of bandwidth in flooding the network with a lot of broadcast messages. So you can look into that. It's quite fascinating. Let's take a look at an example of a DHT. So DHT are table of informations, and it can be, the content can be different based on use cases. So you can really upgrade and use DHT for different things. In IPFS, we use it for two purposes. One is to record peer IDs and where they are. So if it is IP address, then we store IP address. If it is some other address, in a different kind of network, then we will store those addresses. The value can be different based on what you want, and then the ID part, the keys, can be used for other things. So one is to find the peers. The other one is to find the content. So there are two types of DHT table in IPFS, and you can see those examples on the left. And then so that's how files are being stored, and then files are represented, and how files are being found in the network. That explains in a little bit on how IPFS works. But to be able to use it, you will need to either run a node or run a cluster of nodes, of IPFS nodes, to be able to access the network. Or you can pay someone to pin the services for you, like using Pinata or Infura, to actually pay someone to say, hey, well, here's my file on IPFS, and I would like that file to be there for a certain amount of time, and can you please take my money and pin it there for me so I can always access it. You can also hope that your content is popular enough so it stays on the network, but the reliable way is to actually pay someone like Pinata or Infura to host it. That's if you're only using IPFS. The reliable and decentralized way of providing a persistence to a data on IPFS is what Filecoin is trying to solve. So the decentralized and reliable alternative for storing things on IPFS, there are other projects that does the same thing. Today I'm going to introduce the Filecoin project to you. So Filecoin is designed to leverage a crypto-economic incentive to keep data distributed, reliable, verifiably stored, and also incredibly cheap. It is also as permanent as you want to make it, via renewing the deals, whether you want to store data for 5 minutes or 500 years, as long as your storage provider keeps taking those deals. Filecoin is the storage designed for Web3 from the ground up. It is fully compatible with IPFS, and utilizes the benefit of content addressing and CIDs that I just mentioned before. It integrates with Web3 networks like Near and many other. So we have bridges made to different protocols. It will soon be compatible with EVM in the future. Our team is working hard on Filecoin virtual machine that I mentioned earlier at the beginning of the presentation, and eventually it will be EVM compatible, so you can bring your smart contract to Filecoin ecosystem. Filecoin provides verifiable and cryptographic proofs. So the providers, which are mini data centers that stores your data, will be keeping that safe for you, and they will need to be able to prove the cryptographic proof of storing those data safely to be able to receive block rewards. It gives you control over how permanent you want your data to be there. It is also a massive decentralized network. This slide is a little bit old. We now have 18 million terabyte of capacity across the globe, provided by over 4,000 storage providers all over the world. It is governed by consensus instead of a single corporation. So Filecoin Foundation doesn't have control over Filecoin network. The community has it, and there is a community improvement process to improve or change anything on the protocol. So well and truly owned by the community, not by a single organization. So you might have a question about how it works after all. So this is the anatomy of a Filecoin storage deal. A client storage client who might want to store petabyte of data, they will make a time-limited deal first on the Filecoin marketplace, and then say, hey, I would like to store this much data for a certain amount of time. The deal is usually 6 months long or 18 months long right now. And the provider or the storage provider will examine those deals and make offers to these deals. So in Filecoin prices. And then after they have successfully won the deal, they will be taking the data transferred either over the internet or physically over hard drives to their data centers, and then to be loaded to their machines. When they get the data, they will provide two kind of proofs. One is initial proof of replication, or POREP, to verify that they received the client's data. And then the other one is they have to keep providing proof of replication. Sorry, not proof of replication. They have to provide the proof of space-time post to be pushed back to the blockchain, to constantly prove that they're still storing the file, and the files are stored safely and not distorted or tampered with. So if they do, however, their system goes offline or they couldn't provide the proof in time, then they will be heavily slashed. That means they will lose some money during the process. So towards the end of the storage deal, when that ends, the client either need to renew it or let it expire, which means the storage provider will not guarantee that they will be storing those safely. The clients can make a new retrieval deal. Clients can make a retrieval deal to actually take the content away from the storage provider and put it somewhere else, or they can renew it. So so that the content can still persist on the Filecoin. So there's someone asking questions about IPFS, if IPFS is good enough for streaming. So performance-wise, you will have to think about the scale of your application, and also where the content are and where the content are being consumed. So it works very differently than the centralized services. So think about like if you have the streamer, the content provider that is in one part of the world, and then the consumers are mostly on the other part of the world, and there is like 50 nodes across it, then the performance will probably not be good enough for it. But if the streamers like are really close in the same geological area, and the consumers are as well, then it will be pretty good performance for everyone. I will provide the slides after, so if you're lost, please go through that. And also, this talk has been done by my team members multiple times in different hackathons, so you can probably get a better version of what I'm doing right now from my team members recording. So, and also someone's asking a question about specific latencies and storage size, geological location with requesting services. I can't specify that because it works really differently. Depending on where the content is stored and also where the content is read, the latency will be different. There's no limit on storage size on IPFS. It's literally as big as your node can take. It can be a few terabytes if you want it for one file, and it could be as small as 1 KB if you want. The hashing doesn't, so someone is asking if hashing is occurring on the blockchain. No, the hashing doesn't occur on the blockchain. It occurs on the node implementation. And when you can ask IPFS node or the software to actually provide that hashing and CID. That CID after hashed is written on the blockchain as messages. So if it's on Filecoin, then the CID will be recorded in there. And a lot of people actually use CIDs for their NFTs, so that can be written on any chain as a reference to the content. I can see those are the questions. So please do keep the questions coming. It's quite important that we get things answered as we go. So I'll keep going with the Filecoin deals. So by default, the Filecoin deals can be renewed as many times as possible by anyone. Actually, so anyone can come in and say, hey, well, I'm interested in this data. I can renew this data for another 1.5 years or half a year. And we design this way so that over multiple generations that anyone can renew the contract. But this will be changed in the future with the introduction of FEM. So there will be interesting ways of making Filecoin deals, not just renewing it every time manually. The Filecoin deals can also be replicated. So if you want your data to be stored on multiple data centers, you can do it as many copies as you want. We do this for redundancy purposes. So a client might want to replicate it 2 or 3 times in different locations, but they can also do it on all nodes if they like over one deal. So the idea is we're trying to keep the system upgradable. You have Filecoin deals renewing over time, and the number of replications can also happen at the same time. And then Filecoin, the IPFS storage layer is solution agnostic, which means you can combine it with a solution layer of your choice. So if you have hard drives yourself, you can store it over there. You can use mini data centers like our storage providers, but you can also use it to work with cloud infrastructures instead of Filecoin deals to provide a good performance if you want. And Filecoin can be used as a backup. So the IPFS is there for fast, flexible retrieval of file content. So we have gateways, local, you can run local nodes, you can have it running in your browser to retrieve things. IPFS does that very well. And Filecoin is for code storage. So Filecoin is good for persistence and verifiability. So if you don't need something after you store it, do your backup there. Combining these two together will provide a good storage solution for developers because IPFS gives you the fast, flexible way of hot storage, and then Filecoin provides the code storage of your backup, and it's done very reliably. So that's how IPFS and Filecoin marry together. And if you have questions, please continue to ask me. I'll not talk about DevTools. After all, we're here to build something, not just learn about the theories. And in the Web3 stack, you can build it somewhat like this. So imagine you're building a website or a dApp that is a website hosted on the internet. What you can do is you can either host the website and then ask the user to use a DWeb enabled browser like a Brave to use IPFS directly. Literally in Brave, if you type in IPFS : / and use the CID there, it is compatible right now. It recognizes that protocol just like HTTP. It will work. But for the regular browsers, that doesn't work yet with IPFS. We're working on it, like Chrome. You can use a gateway for it. So there are HTTP gateways that brings HTTP protocol into IPFS protocol, and the gateway sort of servers will act as IPFS node to access network and find the content for you. The performance of that depends on the performance of the gateway and how far the gateway is from the content stored in the IPFS network. So from that point on, the user loads the front end from the IPFS, so retrieving all of the files that you have written for front end and loaded on the browser. That's usually how front end gets done. And then for decentralized web applications, we don't like to use centralized ID system. So usually it's logging with a wallet address. And then the bottom layer for storing other content, for example, images, videos, etc. All of these things can be done by using storage helpers. You don't have to manage Filecoin deals and spin up an IPFS node and all that. Quite often you can use a service for that, and that's pretty much turns it into a API integration. So there are websites called NFT.Storage and also Web3 storage and Pinata, S3, these tools to help you to interact, and I'll talk about these next. So one of the things that I'll speak to you about is Fleek. Fleek is like the Netlify of Web3. So if you have a static website or a front-end website that doesn't have server-side rendering, you can link the GitHub repository to this website, and they will crawl the source code from GitHub and then build the websites continuously for you. So as long as you keep pushing things that works to your main branch, it will it will just continuously build that and give you an address that has that website working. It's quite convenient, and I'll demonstrate a little bit. Actually, I can show you right here. This is actually 3 websites that I have published on Fleek. It is free. And you can see that it has the server names, the build pipelines, the current IPFS hash. The Filecoin deal is still being made. And then the most important thing is it gives me a URL to check my website. So over here, you can see that my application, this is a sample application. It is currently running on Fleek, and this website is now served from IPFS to me. And then I can upload files through these sample application that I have written. It's quite easy to use. If I change the coding in my GitHub repository over here and push it to main, Fleek will actually automatically build the new websites and deploy the site for me. So I'll give it a try, but just using Fleek itself to deploy a website is not eligible for a Filecoin price. You have to actually store your data on Filecoin. And this is why I would like to talk about NFT.Storage. If your project is NFT related, please do use this service. It is free forever. And then it practically is a Dropbox for developer kind of deal. It has APIs and it also has SDKs in all major languages. You can use this to upload your image or video or any format of NFT to it, and it will provide free storage for you. Last time I checked, I think more than 61 million files are stored on NFT.Storage, and most of them will be NFT data. We think NFTs are very valuable data for humanity, so it is being sponsored heavily by Filecoin Foundation and the Protocol Labs to keep the service free for everyone. So do check it out. It's quite easy to use, and there are different languages of SDKs out there. So NFT.Storage not only stores things for you, it tries to make the performance of NFT gateways very performant as well. So there's a gateway called Superhot. If you use Superhot, which is I think NFT.Storage link, and then your retrieval or reading of the file will be quite performant. For anything else that is not for everything else that is not NFT storage, you can use Web3.Storage. It's quite similar to NFT.Storage, but it is used for general data storage. So so let's say if you want to store some backend data for your application, you can use Web3 storage and use their SDK to retrieve it, or API to retrieve the files. And it currently has a very good JavaScript and Go libraries that you can send batch files to it, and also it works for quite a large size of files as well. So I get a question. Hello, Jenks. I'm concerning gateway security issue originally affecting IPFS. Is there any advantages added, allowing one CID to interact with resources from another CID, verify whether the content received is what is stored on IPFS distributed file system. So I'm not too sure about the security issue. I'm not quite familiar with it, but perhaps you can send a link to educate me on that. If there is one, it's in my benefit to know about that. From my understanding, the CID, if it is being produced, it represents the true data of it. If someone tried to change it, it will actually result in a different CID. So let's say if you have an image that is NFT, right? That image is highly valuable because someone paid maybe tens of thousands of US dollars for it, and then if the CID of that image is stored on either Pinata or NFT.Storage, and is written in a smart contract, then that should represent well and truly that everything in that image. if someone changes a little bit of that image, it will result in a new CID. Therefore, either smart contract needs to be updated. I don't know how, if it's immutable. And then you can keep it mutable by using IPNS these days. Yeah, so if it changes, then it will have a new CID. So it's one of the benefit of IPFS system. So no one can change it. There are other projects that are using IPFS, this verifiable feature, to make sure that news articles and news content doesn't get tampered with to combat fake news on the internet, because the fact that on IPFS, if you change the content, it will change the CID. So I would like to learn about that security issue to be able to comment on that. So do send me that. How does deal making work? Someone else is asking that. It is actually through the node implementation. So we have 2 node implementation right now. One is called Lotus. So if you install this, then there are actually APIs and command line references that you can use to make a deal. So if I go miners, deals, yeah. So here, this is where you can publish the deals and take deals and all that. So the miners are actually using this, or storage providers are using this to manage all of the different deals. And can use smart contract to own storage and do deal making. I don't know if that's been done yet. So we don't have smart contract yet. We're working on a Filecoin virtual machine, and it will be programmable from October. So I think from October, you can try to make those deals automatically happen on Filecoin. But until then, yeah, I haven't seen a project that uses like Ethereum smart contract to make deals and talk to Filecoin yet. That's it seems like an interesting idea for that. You might be onto something right here. There's also another node implementation called Venus. So that's another software. And then it also does deal management, etc., and all that. Yeah, there's deal services here. Yeah. So I went off a tangent there. There are some more powerful developer tools out there called Powergate or Textile. It provides a really beefy backend to developers. It goes pretty deep, and it uses more of the powerful features of P2P, IPFS, and Filecoin. And also it has the bridges near protocol, Polygon, Ethereum, and others. So you can use other currencies to make Filecoin deals or interact with Filecoin. And how it works is written in the documentation. I actually haven't had a lot of experience in that. So if any developers have some feedback or something you would like to share with me, I'll be more than happy to learn from you. So what we're seeing here is actually the Web3 architecture. So to developers who are interested in this, the front end gets built and then it can be stored. There's like dotted line on the right. It can be stored on Filecoin, the IPFS node, the front end code. And then the logic part, you currently rely on either building the logic on the server that you own or using Ethereum, Near, all these other wonderful protocols that has a good smart contract ecosystem. Use them to execute the logic layer of your application, or wait for FEM, which will be too late for this hackathon, but then in the future you can use FEM to do it. And then for storage layer, like if you need to store files or anything like that, you can use SDK hosted APIs or public APIs to actually talk to the Filecoin IPFS nodes there. So you do not need to actually make a deal on the Filecoin network and use Lotus or Venus to interact with Filecoin. You can just use these storage helpers like Web3.storage or NFT.storage or S3.tech. These are 3 options that you can use. So hopefully get an idea on what to use in your hackathon project. I highly recommend NFT.Storage if you're doing anything NFT related, and Web3 storage for general purposes. And then you can use S3.tech for more advanced usage of Filecoin. So S3 actually manages the deal for you. You can, it's able to make deal making very simple. And if you use S3.tech, you can apply for API key and get issued in a couple of days, the API key. The system is wonderful, actually. So no matter how small your data is, it will always make a deal. Whereas on the actual Filecoin network, if your storage deal is too small, some of the data centers will not take it. So S3 sort of takes it away, because on S3, all of the files that you upload is verified deal, and verified deals will have higher reward. The miners will get higher chances of getting a reward. So they're almost are always going to take your deal on S3.tech. So Filecoin use cases and projects, we often show these ecosystem diagrams to people. These are some of the well-known projects that are using IPFS. You can see some, maybe you can see some logos that you know. It shows that a lot of people are using us, IPFS, and it really powers the Web3 ecosystem behind it. And then same for Filecoin ecosystem, we do have different technology partners that are using it. We have also research and collaborations, and also token infrastructure of the developer tooling companies, and also ecosystem collaborators in there. So there are lots of people having really good relationship with Filecoin as well. These are a few people that are using IPFS and Filecoin, or Filecoin mostly. So the Internet Archive is storing election data, US election data after 2016. All of their data are stored on Filecoin. Starling Lab is using Filecoin to store their research data. And then Audio's Live Peer, OpenSea, all have different kinds of integration with IPFS. Huddle 01 is using IPFS to power their video streaming services, or video conference services there. So IPFS Filecoin aims to provide scalable storage for the next 1 billion NFTs and Metaverse. We're approaching it. 61 million NFTs stored on NFT.Storage alone. There will be more stored somewhere else as well on Filecoin IPFS. And then we're trying to get involved in the metaverse as well. So if you have project that involves in ticketing, game assets, music, AR assets, documents, and POAPs, you can consider using IPFS and Filecoin. These are some of the project ideas that we kind of give to hackers if they're running out of ideas or don't know where to start. Please feel free to take a screenshot of this and think of something interesting or similar to these to build to. It really, like, storage underpins everything we do on the internet. So if your project has any kind of storage, unless everything passed through or it's a completely a pure finance project, you will have some chances of using Filecoin and IPFS. It may not be core to your project, but you can always find something that you need to store on the network. So we're not only just a technology project, we're also trying to do some social good in the world. So one of the projects that I want to mention is Filecoin Green. Some of the blockchains can be quite intensive in energy use. Filecoin Green is an initiative that is trying to make Filecoin blockchain carbon neutral and in time carbon negative. It is not only trying to make Filecoin chain greener, but the underlying technology that is produced by this project will be shared with other projects. So other blockchain companies or protocols can be as green as they want as well. So follow them if you like. Go to filecoin.io/blogs posts Filecoin Green. They will be posting their updates there. and the video shown here. If you search on YouTube Filecoin Green right now, you'll be able to find this video that we're doing a lot of updates there. Filecoin Foundation for the decentralized web. So Filecoin Foundation also has an arm for not-for-profit, and they're in general trying to make a lot of good initiatives to help development of open source softwares, but also they're doing charitable activities to preserve human important data sets, so such as web community data or any educational data that people wants to store but doesn't have spaces to store. We will provide the free storage to these organizations to store them. There are a few organizations that I mentioned earlier that are using Filecoin services to make sure their data is persistent on the internet for as long as 50 or 100 years. Filecoin Plus is an amazing notary program that certifies the data. So earlier I mentioned that the Filecoin Foundation for Decentralized Web and many other organizations are trying to store humanity's important data on the network. Filecoin Plus is actually the governance project to make sure that the data we stored on the network is valuable. The way to make things valuable or to make sure that they have some value is to borrow the hands of notaries. We have over 100 notaries around the world now, representing different geographical area, and they are actually the verifier of these data. So if they say this data is verified, they will be given data caps, which are storage that can give storage provider more incentive to store the data, and that's how we improve the quality of data through this Filecoin Plus program. Also, Filecoin Plus program is sponsoring the NFT.Storage and Web3.Storage. The first terabyte is free, so these are all coming from the good of Filecoin Plus program. I should say generosity of Filecoin Plus program. We're doing a lot of social good use cases for different organizations. These are a few. I will not mention them again. I've mentioned a couple of them already. The rest of them you can kind of read on at leisure time. There are a couple of exciting projects in Filecoin. One of them is we're building, Filecoin is really good at storing things into those storage providers and in the data centers. But retrieving that, as I mentioned earlier, you will need to make a storage deal to actually retrieve it. And because the data are securely sealed in the hard drive, it takes time to actually serve these. So imagine putting a piece of food into fridge. It takes time to actually freeze it in the cold. It's cold storage, so let's use a freezer for analogy. And when you want to use it, you need to defrost it before you can use it. So it takes a long time to actually retrieve the data right now. We're working on it. The internet obviously requires better solution than that. So one of the projects to do that is the decentralized CDN network. So we're trying to build a retrieval.market, which is a decentralized CDN based on Filecoin network, and it serves Filecoin network first. And right now the CDN network, content delivery network or content distribution network, is highly centralized. It's controlled by internet companies and also cloud companies. And Filecoin is trying to build a decentralized version of that. There are a few projects working on it. There are 10 grants in process. It is not just Protocol Labs or Filecoin teams building that. We also invited community teams to build some parts of it, some moving pieces of it. And there are a lot of contributors to this project right now. And also Filecoin virtual machine is coming, as I mentioned earlier. It is putting smart contract Filecoin protocol. It is so it's more than just storage. So we already have a lot of data stored on Filecoin network. The idea is that if we put logic layer on it, then we can do a lot more than just storage. So you can consider Filecoin as a layer 0 storage protocol made from the ground up, and the chain that we have is providing, so if we have Filecoin virtual machine on it, then we can provide computation over stored data. And then we can also enable layer 2 to be able to do even more, like DeFi is a possibility, different kinds of renewal of deals, new kind of data deals, and also NFTs are all issuing tokens or possibilities. So hackathons will be a lot more interesting with Filecoin after FEM is introduced. I'm really looking forward to this. How to get involved? There are heaps of resources to get involved, but I would like to ask you to go to the hackathon.filecoin.io. There's a getting started link on the website. So let me show you right here. And alternatively, you can also find out the Filecoin YouTube videos and go to our documentation site. So in here, we list all of the hackathons that we get involved in. And then there is a getting started link right here that leads you to a Notion page that we carefully curated with lots of tutorials and links to talk about how to use IPFS. You know, how does it actually work? The parts that Jenks didn't explain in this workshop, it's all included in here, including a lot of demos and examples. And I mentioned earlier, there are better versions of this talk recorded on the internet. It's all here. So have a look, please. hackathon.filecoin.io. We have heaps of stuff on grants and also on GitHub as well. And then one of the ways to get involved, if you have questions here, please join our Discord channel and also Slack channel. So that's a way to ask bespoke questions. I'll hang around in the hackathon, in this hackathon's channel myself as well. So if you have any questions, you can feel free to raise it to me directly. You can also book meetings after this hackathon. If you want to talk to one of us, the developer advocate team, you can book office hours, and we also host weekly office hours on Fridays or Thursday in North American time to talk to the community directly. A few of us will hang out there and answer your questions. So that's all, hackers. I'll take a look at the questions in the channel and see if there are some interesting. How do you search if you don't have content ID? Okay. So that's a good question. That's a really good question. So IPFS actually doesn't, because there's lack of central authority, a centralized server, it actually doesn't know what content is on there. So one way to do that is hash your content and then see if that content can be retrieved by gateway, but that you could get a timeout from it. And the other way is using indexers. So there are index services that index all of the content on IPFS. I haven't used them myself, but they should work quite well. I think the Graph has the Graph project actually has a indexer, IPFS index. So let me see, indexing. So in their documentation, let me see, IPFS. IPFS API. So over here, Anchor. Okay. I think this is not the same thing, but I've spoken to the Graph protocol people, and they said they're actually providing an indexing service for IPFS, and some of the content are indexed there, if not a majority of them. So yeah, I will be making the slide available to you all after this, and I'll send the PDF there. Yeah, so sorry, I probably couldn't find the exact solution for you for your question, but yeah, hopefully you get some. You can find some solution on the internet as well. I can feel free to ping me. Join our Slack channel, as I mentioned earlier. So over here, where is it? Discord Slack. Oh, you can find the Slack on IPFS Filecoin.io and join the Slack channel, and you can find Jenks there and chat to me directly about this if we can explore it together.
I'll post it here. There's the Slack.
Cool. Nice.
Jenks, thank you so much.
It's a pleasure to be here. Yeah, so many good questions.
And it was so lovely having you. Thank you for, like, it's 12 o'clock at night for Jenks, probably 1 o'clock in the morning now. So thank you so much for waking up for us and for giving us this workshop. We all really do appreciate it. And it was fantastic. And to everyone else, thank you so much for coming. Thanks, guys. It was so lovely having you all. And again, Jenks, thank you so much for taking this workshop. We all
Thank you, Alex. Thanks,
it.
everyone.
And again, if you have any technical questions, ask it in the Discord channel. Jenks is there and he will help you out. Awesome. Have a lovely day.